The theme of our eighth lecture is electric current in gases. At this lecture, you will learn about ionization and recombination of gases, current nature in the gases, volt-ampere characteristic of gas discharge, non-self-sustained discharge in gases, types of self-sustained discharges in gases. And at last, we'll consider glow discharge, spark discharge, crown discharge, and the arc discharge. Crown discharge sometimes is called the corona discharge. To understand this lecture, you will need this next vocabulary. Gas discharge, газовый разряд. Non-self-sustained discharge, не самостоятельный разряд, өздік емес заряд. Self-sustained discharge, самостоятельный разряд, өздік разряд. Saturation current, ток насыщения, қанығу тоғы. Breakdown voltage, напряжение пробоя или напряжение зажигания иногда называют. Glow discharge, тлеющий разряд, солғын разряд. Spark discharge, искровой разряд, ұшқынды разряд. Arc discharge, дуговой разряд, доғалық разряд. Corona discharge, коронный разряд, тәж разряды. What is electric current in gases? So, electric current through gases is called the gas discharge. Gases under normal conditions consist from electrically neutral atoms and molecules, and therefore they are not good electrical conductors. Air under normal natural conditions has little conductivity caused by partial ionization of it by cosmic rays and radiation elements that are always in small numbers on the ground and in the air. To make the gas conductible, we must ionize its neutral atoms and molecules. Gases are ionized under the influence of outer space, X-rays or radiative rays due to the collision of atoms with fast electrons or other elementary or atomic particles, at heating of gases, and so on. During ionization, an ion-electron pair is formed. EDS, free electrons and positively charged ions appear. If an atom gains an electron, it becomes a heavy negative ion, but they are generally few in number and not important in gases conduction. Ions and free electrons in the ionized gas are in constant random motion. Due to Coulomb force of attraction between opposite charged particles, they combine to form neutral atoms and molecules. This process is called a recombination. When an electric field is applied between two electrodes in the ionized gas, the charged particles move in a specified direction, and electric current flows in the gas. Thus, the electric current in the gas is the motion of positive ions towards the cathode and electrons towards the anode. So during these opposite directions, they can recombine. And during this recombination, light is produced. When the number of ion pairs generated by the ionizer will be equal to the number of neutral atoms and molecules formed during recombination per unit time. It is said that the dynamic equilibrium is established. So there is a new notion as dynamic equilibrium. It happens or occurs when the number of ion pairs generated by the ionizer will be equal to the number of neutral atoms and molecules formed during recombination per unit time. The recombination of ions is accompanied by the release of energy, mainly in the form of light radiation. That is why the gas discharge produces light. When the ionizer stops working, the recombination of ions exceeds the generation of ion electron pairs, so the number of charges decreases to 0. Discharges in gases are divided into non-self-sustained discharge and the self-sustained discharge. So, the current voltage relation curve of electric charge in gas is given in this picture. So that is, we call the current voltage relation for an electric discharge in gas. As the potential difference, so this curve is divided into several parts. So first we will consider the part OA. This part shows that while the intensity of ionization remains constant, the electric current varies linearly with the change of the potential difference. So the potential difference increases, and so the current also increases. And at this part, the electrical discharge in gas obeys the Ohm's law. The higher or the greater is the voltage, the greater is the current. As the potential difference increases, the ions travel more quickly, and there is less opportunity for recombination. The ionization current increases. The dependence of the current voltage becomes non-linear. So that is the part between A and B. It is non-linear relationship between current and voltage because the number of ions increases. At B, all the ions produced by the radiation reach the electrodes. No recombination occurs, and further increase of the potential difference between B and C does not affect the current. So you see at B, the number of ions does not change because the intensity is constant of the light of the ionizer. And with increasing of the voltage, the current does not change. And this current is called the saturation current. I saturation current is called. So let us make summary of our lecture. Electric current through gases is called gas discharge. Discharges in gases are divided into non-self-sustained discharge and the self-sustained discharge. The potential difference at which non-self-sustained gas discharge becomes self-sustained is called breakdown voltage. There are several types of the self-sustained discharge: glow, spark, arc, and corona discharges. The types of discharges depend on the gas pressure, the shape of electrodes, and the characteristics of the external circuit. The lecture is over. Thank you for your attention.